Let's talk about benzene and some of its derivatives. One thing to point out, though, before we take a look at the structures of derivatives of benzene, is that when we have multiple functional groups within a molecule, although this is something we'll focus on more later on when we talk about carboxylic acid derivatives, for the derivatives of benzene, the order of preferring the name of that compound as your parent follows the following order. A carboxylic acid will always be highest priority. Of all the derivatives of benzene that we're going to study, the next highest priority is the aldehyde, followed by the ketone, the alcohol, the amine, various alkyl groups, and then lastly the ether of benzene. And so we're going to see here that a lot of benzene derivatives have very specific names. These are not systematic names necessarily. They are common names, but they are preferred by the IUPAC because they're efficient. So unfortunately, you will need to learn all of these names. Let's start with our highest priority one, which is the acid. So if our benzene has a carboxylic acid on it, it is called benzoic acid. Pretty easy. If we have an aldehyde, and these are only currently monosubstituted benzenes, we're going to see we can put other groups on, which will also influence our naming. The aldehyde form is called benzaldehyde. So far, so good. So benzaldehyde, benzene with an aldehyde, hooray. However, if we look at the simplest ketone we can make with benzene, that of a methyl ketone, this is now called acetophenone. Aceto for the single methyl group there, phen for the phenyl ring, and then one for ketone. So we're starting to get some weird names here. If we now look at the alcohol, this one is called phenol. Phenyl alcohol, which is condensed to phenol. Just like ethanol is ethyl alcohol combined to make ethanol, right? So phenol. Following next is our amine. The amine is a nitrogen instead of an oxygen. This is called aniline. Continuing on, we have some of our alkyl-based groups. If we have a double bonded carbon coming off of our benzene, this is called styrene. Most commonly, you'll see something called polystyrene. That's one of our pretty common plastics. Perhaps the most widely known polystyrene is styrofoam, which is air in a matrix of polystyrene. Few more. If you have two methyl groups on your benzene, it is called xylene. And I'm going to put an asterisk on that because we're going to come back. There's multiple different xylenes. For example, I have those two methyl groups adjacent to each, on adjacent carbons. But there are other places to put them in, so we'll look at those xylenes later. We have one more alkyl group with just a methyl. This is called toluene. Pretty common paint thinner, smells like gasoline. Pretty common. And lastly, we have our methoxybenzene, which is called anisole. So that one, I have no idea where that name came from. So unfortunately, can't help you there. So there are these 9 benzene derivatives that all have special names. And they're all going to need to be memorized, unfortunately. So you'll want to be comfortable with all of these various substituted benzenes. because we're going to see that if we have multiple substituents on the benzene, we are going to probably refer to one of these as the parent names if they're present. For example, if we have the following compound, we have now a chlorine on our benzene. We want to identify the parent name of the compound first, right? Just like we would identify our longest alkyl chain if we were looking at alkanes, alkenes, alkynes. Always look for the longest chain, right? That's your parent. Here with benzene, we're looking at potentially one of these to be our parent structure. And so we have two substituents on our benzene here. We have an alcohol and we have a chlorine. So we're going to look at our list here. Do we have either of those? We don't have any in the first row. We do have an alcohol. Remember, by the way, these are hierarchical names. So benzoic acid should be given priority if you have an acid. Name your structure as a benzoic acid if you have an acid present. So since we have an alcohol present, that's our fourth priority, but we have nothing higher, we're going to name this as a phenol. It's going to be a substituted phenol. Once we've identified our highest priority group, we're going to assign the locator numbers. Your locator number that is lowest should always go to the carbon that holds the highest priority group. So this will be carbon 1. And of course, because we always want the lowest number of carbons, we will assign the chlorine to position 3. Right, the other option, if we started counting the other way, would be 5, but we always want the lowest possible numbers. So we would simply call this 3-chlorophenol. Fortunately for us, there is no stereochemistry associated with benzenes because they're completely planar. So we don't have to worry about R and S here because there's no extra configurations we can have. Let's take a look at another one. As with before, we'll want to identify our substituents and see where they are on our list of priorities. So it looks like on the top we have a methoxy group, and on the bottom we have a carboxylic acid. So going back up again, let's look at our highest priority. We have a carboxylic acid. That is always highest priority, which means this compound should have the parent name benzoic acid. So that means we have our parent name already. So our carbon number 1 is the one to which our acid is attached. And no matter which way we number this, we're going to end up with our methoxy group on carbon 4. So we'll call this 4-methoxy benzoic acid. So with naming di-substituted benzenes, we also have a special way of doing it, just to make things complicated. And let's take a look at those xylenes. So with xylene, we have 3 options of how we can arrange the 2 methyl groups. We could have them on adjacent carbons, carbons 1 and 2. I'm just going to label these. Again, it doesn't matter which one you're numbering 1 and these are just for reference, right? We could call these, 1,2-xylene or something, 1,3-xylene, but we have other words that we're going to describe. On a di-substituted benzene only, meaning you only have 2 substituents, not 1, not 4, not 3, not 6. Only with 2 substituents can you use these names. I will write that down here. Only use these names for di-substituted benzenes. And those names are going to be ortho, or O. They're right next to each other. They're called ortho. We have meta, or M. And we have para, which is P. Now, these names might be a little bit familiar to you, as back in spectroscopy we talked about how para-disubstituted benzenes had very specific NMR peaks, right? We're going to see that anytime we have two substituents and only two substituents, we can, instead of using numbers, refer to their relative location to each other. So, these are all xylenes. We have orthoxylene, metaxylene, and paraxylene. And together they form a family of compounds called xylenes, all of which are dimethylbenzenes. We can see we can also apply these terminologies, ortho, meta, and para, to the previous two examples. We could have called this metachlorophenol instead of 3, and we could have called this para-methoxy benzoic acid. So either of these names will work. They're both acceptable. There's no preference for one over the other. However, later on, we're going to be using the terms ortho, meta, para very frequently. So it's probably a good idea to familiarize yourself with them now. And note again, one more time, these are only for disubstituted benzenes. As soon as you have 3 things or more, you have to use locator numbers. So in this case, phenol will be our parent. We always want to assign the lowest numbers possible. So even though, in no other situation would we rearrange these, right? So 3 and 4 will be our locator numbers here. We don't need to put the 1 because we know the 1 will be part of the parent name. But we still have to rearrange these alphabetically. So bromo comes first. We have 3-chloro, and then phenol. We have to use locator numbers because we have 3 substituents on. And we're going to see that the same sort of nomenclature rules from naming compounds last semester will still apply here. And we'll do one more example. Ooh, how about we have got an alcohol, and let's have an aldehyde. So we have 3 substituents, so we can't use any fancy names, only numbers. And in this case, we have all 3 different priorities here of our functional groups. So let's go back to our list. We see in this compound we have an aldehyde, an alcohol, and an amine, so they should be in that order. So the aldehyde being highest priority will take the parent name, and then we'll have the alcohol and the amine as substituents. So we know that this will be benzaldehyde as the parent name. And we have to decide now, which way are we going to go with this? Well, you always want to give your second highest priority group the lowest possible numbers, if there's ever a discrepancy. So we're going to number towards the alcohol side, so that our priority list stays the same. And so we'll have now, in alphabetical order, 5-amino, 3-hydroxy benzaldehyde. And so hopefully these examples make sense, and you can start practicing your skills on naming right away.